Hello friends, I am Aryan Guru, working as Assistant Professor in Civil Technology, College of Engineering, Hyderabad. I am dealing with Surveying 1. This is Module 1, Lecture number 6. So friends, in this lecture we are going to see what is use of surveying, what are the different type of maps, what is the difference between plan and map, what is scale and their types, and how to set the perpendicular offset, and how to enlarge or reduce the given figure. In this slide we are going to see what are the uses of surveying. So surveying is to be carried out for preparing maps and plans, in which we are trying to record the linear measurement, angular measurement to prepare plan and map. So the first use of surveying is to prepare a topographical map, in which we can show the hills, valleys, river, forest, villages, town, etc. Similarly, to prepare a cadastral map which shows the boundaries of fields, plots, houses and other properties, we can make use of survey. To prepare an engineering map, which includes the engineering works such as buildings, roads, railways, dams, canals, etc. are shown on a map, and the map is called engineering map. Next is a contour map. Contour map is drawn to know the topography of an area, to find out the best possible site for road construction, railway, bridges, reservoir, canal, etc. And to prepare military maps, geological maps, archaeological maps, etc. This slide refers to a topographical map, in which we are trying to show the forest area, the location of river, location of sea, boundaries of different countries. This slide refers to cadastral map, in which we are trying to show the roadways, buildings, open spaces, agricultural area, and the exact location of private buildings and their plot locations. This slide refers to engineering map. Generally, in the engineering map, we are going to show the roadways, railways and the airport locations. Even in the engineering maps, we are going to show the location of dams, location of canals, nalas also, and the adjoining buildings, different zones which are coming under a given area. So this particular slide refers to contour map. Generally, a contour is a line which is going to join the points of same elevation. Here in the map, when the number of survey lines exist, then we are going to call that particular map as contour map. In the contour map, you will observe the various values which are assigned for a particular line. They are 100, 200, 300, 400, 500 and 600. So whenever the value of contour increases, it indicates the increase in the level with respect to the datum. So therefore, in the given contour map, a hill feature is shown. This slide refers to geological map. This is a geological map of India, in which different color codes are shown in order to represent the availability of different rocks such as sedimentary, igneous, metamorphic rocks. This map refers to military map. This is a map representing Jammu and Kashmir location and the surrounding countries and the areas under control of different countries has been shown as a LOC, and which is approximately shown with the help of the different color codes. This is a slide related to archaeological map. This is the tourist map showing the sites and monument in India, so that it is possible to visit the given sites or cultural sites because of its historical importance. In this slide we are going to see the difference between plan and map. So plan is a graphical representation to some scale of the picture on, near or below the surface of earth as projected, whereas map is a graphical projection on a horizontal plane where the projection is small and the plan is called map. Then we'll see what is the exact difference between map and plan. So we can study a part or whole of the earth with the help of map, whereas in case of plan, details of small areas can be shown. In a map contains lot of information, whereas in plan details are given in the form of symbols. Then in a map it shows very important feature of the area, whereas a plan can show the length and breadth. Similarly, the scale of the map is maybe 1:10,000, means 1 centimeter on paper is equal to represent 10,000 kilometer, whereas in case of plan the scale adopted is 1:100. It is going to represent 1 centimeter on paper is equal to 100 centimeter on the ground. This slide refers to the difference between map and plan. In this slide we are going to see a scale. So scale, it is the basic requirement for the preparation of plan or map. The proportion or ratio between the dimensions adopted for the drawing and the corresponding dimension of the object. The next is representative fraction. Generally we are going to call it as RF. It is the ratio of distance on the drawing to the corresponding actual length of object on the ground is known as representative fraction. It is denoted by RF. Representative fraction, that is dimension on the drawing divided by dimension of an object, or RF is length on drawing divided by actual length. This slide represents scale and its construction. In order to construct the particular scale, we know the data such as a representative fraction of scale, unit, and the maximum length. This slide refers to the scale. Scale is a fixed ratio that every distance on the plan bears with corresponding distance on the ground. 1 centimeter on the plan represents some whole number of meter on the ground. For example, 1 centimeter equal to 10 meter. Generally, this type of scale is called engineering scale. 1 centimeter equal to 10 meter. Similarly, 1 unit of length on the plan represents some number of same unit of length on the ground. That is 1:1000. So this is representative fraction scale. The ratio of map distance to the corresponding ground distance independent of unit is called representative fraction. The ratio of map distance to the corresponding ground distance independent of unit is called representative fraction. For example, 1 centimeter equal to 50 meter is a engineering scale. So to convert the engineering scale to representative fraction, the representative fraction can be calculated as 1 divided by 50. So 50 is having unit meter. So in order to convert the meter into centimeter, we are supposed to multiply by 100. So 50 multiplied by 100, it becomes 5000. Therefore, the representative fraction becomes 1 divided by 5000. So here, whatever the unit we take at numerator and denominator, they are same. This slide refers to scale and their types. Generally, plane scale and diagonal scale, these are the two scales which are used. So plane scale is the most commonly used in maps to represent two consecutive units, that is unit and subunit. The scale is not drawn like ordinary foot rule. If a scale of 1:40 is to be drawn, the markings are not like 4 meter, 8 meter, 12 meter, etc. at every 1 centimeter distance. So this is called this is called plane scale. This slide refers to construction of plane scale of RF 1:500 and to indicate a distance of 66 meter on it. So in this problem, if the total length of scale is selected as 20 centimeter, means we are going to make use of 20 centimeter scale length. It represents a total length of 500 multiplied by 20, that is equal to 10,000 centimeter, and 10,000 centimeter is equivalent to 100 meter. Hence we have to draw a line of 20 centimeter and divide it into 10 equal parts. Hence each part corresponding to 10 meter on the ground. First part on extreme left is subdivided into 10 parts, each subdivision representing 1 meter on the field. Then they are numbered as 1 to 10 from right to left as shown in the figure. If a distance on the ground is between 60 and 70, then it is picked up from a divider by placing one leg on 60 meter, that is on the right part marking, and other leg on the subdivision of the first part. Thus field distance is easily converted to map distance. So in this slide we are going to see the diagonal scale. In plane scale only unit and tenth can be shown, whereas in diagonal scale it is possible to show units, tenth and hundredth unit. Unit and tenths are shown in the same manner as in the case of plane scale. This slide refers to the scale. Scale is a fixed ratio that every distance on the plan bears with corresponding distance on the ground. 1 centimeter on the plan represents some whole number of meter on the ground. For example, 1 centimeter equal to 10 meter. Generally, this type of scale is called engineering scale. 1 centimeter equal to 10 meter. Similarly, 1 unit of length on the plan represents some number of same unit of length on the ground. That is 1:1000. So this is representative fraction scale. The ratio of map distance to the corresponding ground distance. This slide refers to construction of diagonal scale. So in this particular diagonal scale, the distances are shown in kilometers, and on the left of 0, the length is divided into 10 equal parts, which is going to represent 10 km, so that it is possible to indicate the different distances such as 222, 336, 459 and 569 km. So this slide refers to setting the perpendicular on the field. Here the AB is a reference line, and we are interested to set the perpendicular at a point C, which is going to make an angle of 90 degree to the survey line or baseline at D. So for that we are supposed to make use of the instrument such as open cross stop, or we can make use of fringe cross stop, or even we can make use of the optical square instrument. And for that we are supposed to hold the ringing rod at A and C. So simultaneously 2 persons are required, and one is going to have the ranging rod position A. Similarly, another person is going to have the ranging rod position C, and when they are going to meet and when they are going to coincide, then the point D is the foot of perpendicular for that particular offset, and the distance AD is the chain edge of point D. So this particular slide refers to plotting the two lines. So this is a page of a field book. Generally the two lines which are drawn at center. Here in this particular diagram, A and B, these are the two surveying stations which are shown with a triangle. They are called station point A and B, and on the left as well as on the right of line AB, they are the objects, and the dotted line indicates the offset, and these offsets are going to make an angle of 90 degree to the survey line AB. Therefore all these offsets are called perpendicular offsets. And on this particular line AB, 5.3, 7.85, 12.15, 14.7, 15.3, 18.6, whatever the measurement which are written, they are called chainage. So chainage is the distance of any point lying on a survey line from starting station. Means if I consider 14.7 distance on a line AB, so it indicates that whatever the offset which is taken is located from station A along line AB at a distance of 14.7 meter. Similarly, if I consider the last object which is located at 23.05, it indicates that the distance between the last object from starting station A is located at 23.05 meter, and the last object is located on the left side of survey line AB. And whatever the distance we are going to call, that particular distance we are going to call it as a offset, since it is the lateral measurement taken from the survey line or baseline. We can take a scale, 1 centimeter equal to say 2 meter, and if the length of say AB is say 50 meter, then the length on the paper should be 50 divided by 2, that is 25 centimeter. Similarly, while plotting the exact location of chainage A, that is 5.3, we have to divide 5.3 by 2, and whatever the distance we are going to get will be plotted from station A. Similarly for all the points. Then in this particular slide we are going to see how to enlarge a figure. So it is essential to retain the similarity when the given figure is to be enlarged. Consider the figure 134 which is shown. It is possible to reduce and enlarge irregular figure. Let A, B, C, D, E be an irregular pentagon which has to be reduced in size, so that AB is now converted to A dash, AB dash. All the other side of the figure are to be reduced proportional. So for that, draw the figure A, B, C, D, E. On AB, mark B dash, marking AB dash the required length, and draw the diagonals AC and AD. Draw B dash C dash parallel to BC, C dash D dash parallel to CD, etc. until the figure is completed. Figure 134 is similar to the preceding one, but this time AB, CD, E has been enlarged so that AB now becomes AB dash in length. Hello, thank you.